Hi, my name is Thomas Lin. I'm with the University of Toronto, and I'm here today to show you how to use Nova's Python clients to programmatically boot up virtual machines or VMs on the SAVI testbed. So along the way, I also hope to be able to show you some tips and tricks about how to explore objects in Python. For the purposes of today's hands-on walkthrough, we will be using the Client 1 machine, which you should all have access to already. And so right now I'll give you an opportunity to log in to Client 1 if you haven't already. Then I'll give you a few seconds to do that. So today we will be doing this walkthrough using the Python shell. So to start the Python shell in Client 1, simply just type Python, and that'll start the Python shell. So one thing to note is that we are using Python 2.7, not Python 3. So the Python shell is basically, it's a scripting environment, and it allows you to really quickly prototype small snippets of code such that you can essentially improve their functionality. Once you know that a certain sequence of lines will work, you can copy and paste those functional lines of code into a separate file, and that'll essentially be you starting to build up a script, right? And so once you can build up a script, then you can simply execute the scripts to do whatever you want. So the goal for today is to show you just enough such that you can create a simple script to boot up a virtual machine. So if you haven't already, start the Python shell. So I will do that here in this terminal for you, and hopefully I'll make this big enough for you to be able to see. So now this starts the Python shell. So one thing to note is that in all your accounts, I've enabled tab completion for Python within all your accounts. And so you'll come to see how this will help you explore Python objects in a little bit. So before we get started with the Nova client, we have to import the client itself. So in here, we just have to run this line, import Nova client version 1.1 as Nova client. So this itself is not the client yet. So in order to create an instance of the client, we have to be able to supply it with the username and password and tenant and region that was assigned to you in lecture on the Google Docs spreadsheet. And similar to the command line commands that you saw earlier, you need to be able to set these parameters here as well. So let's begin here. I'll create a few variables to store my credentials. So my username, I'll call it NetSoft50. And my password, because I haven't changed it, will be the same. My tenant's name, I will set this to workshop 2. My region, I will set it to 4. And the authentication URL, which should be the same for all of you, should be this, right? So now that we have these credentials saved, we are ready to create an instance of the Nova client. And that is essentially what this line will do. So this will create an instance of the Nova client using the credentials that we have just created. Region name equals reg. Press enter. So this is simply an instance of the Nova client. So when I mentioned earlier that I've enabled tab completion for all of you, you can now see how this will help you explore objects. So this Nova client is essentially an object, right? So if I type Nova dots and then I press tab, now sometimes you have to press tab twice, you'll see a whole list of potential things pop up that can auto-complete after the dot. And all these things are the potential object member variables and object member functions that are within Nova. You can differentiate between member variables and member functions because of the fact that member functions will end with this opening parentheses here. Everything else is a member of a variable. And some of these variables may themselves be objects as well. So as an example, the equivalent to typing nova list, the command nova list in the Python CLI, in the Python, sorry, not Python CLI, in the CLI, you can usually type nova list to list the servers, right? So in this case, if you want to list the servers, the VMs actually that currently exist, we just have to do nova.servers.list. And right now, this returns nothing. And so to show you the equivalence, let me make this bigger. So basically, what we did in Python just now, I'm doing here, nova list. So in the bash CLI, nova list would normally show the list of servers. And so as we can see, it returned nothing. This returned an empty list right now, and this returned no servers. So this is a little bit boring. How do I prove that these two things are equivalent? So in this case, let me try booting up a few VMs really quickly here, just so that we can see what's going on. So in another console, let me quickly create a few VMs. So I am launching two VMs here. So in the bash CLI, if I type nova list again, we can see that there's, let me make this smaller. We can see that there's two VMs currently being built, right? So we can see the same thing here if I go back to the Python shell. If I go to nova.servers.list again, I now see two server objects being created. So this allows you to programmatically in a Python script or a Python program be able to query the status of the SAVI testbed. And so you notice that this creates two objects of type server within a list. And it's a list because it's within these square brackets. So let's actually explore one of these objects to see what they have. Well, actually, before I get there, similarly, in the CLI itself, let me switch back here. We can also do things like, for example, nova flavor list, correct? Or we can do even nova image list. All these commands have their equivalents in the Python shell. It's in the Python shell itself. So for example, I can do nova.flavors.list. And that gives me a list of flavors as well. And each of these is a flavor object. But okay, so now let's try and examine one of these flavor objects. So if I do nova.flavors.list, let me get the first item, the item at index 0, and let me save it to a variable called a. So now I can see that this is a flavor object called m1.time, right? So if you're ever curious about what are the member variables and member functions within an object, I've already shown you that you can do the object dot, and then you just press tab for auto completion, and it'll pop up. An alternative way that you can do this is you can use the dir to list all the member variables and member functions within an object. So this is another way that you can explore objects within Python itself. So one thing that you should have noticed is that one of the member variables within this flavor object, which we've saved to A, is a member variable called name, right? So we can see that here, and we can also see that up here. So what is name? Well, let's see if it's a function or if it's an object or whatever it is. So if I go a.name, I can see that it's a simple string with, as expected, the name of the object, right? So and more specifically, the name of the flavor. But what if we are trying to find an object within that list? So earlier when we did this, there's a lot of flavors. How do we just find a certain one if, let's say, I'm given a name? How do I just get that object? Well, one thing I could do is I could, in a loop, iterate through this entire list of objects and then one by one check if its name matches the name that I want. But let's say that I know the name. Well, Nova actually comes with a find function for many of its sub-features. So if I have novas.flavors. I can do find. If I know the actual member variable label itself, in this case its name, I can go name, I'm looking for name equals, say, n1.small, which is the name of an existing flavor. So I can do, let me save the results to flavor. So essentially, under the hood, Nova is going through the list for you and trying to find a corresponding object who has a member field called name equal to n1.small. So if I type flavor right now, you can see that it successfully retrieved the flavor object n1.small, right? And this find function isn't limited. This find function isn't limited to just the flavors. So another common command that you may be familiar with in the bash CLI is image list. So if I go back here, right, I can do Nova image list to retrieve the list of images available. And as you can see, it's a long, long list of potential images, right? So let me come back here to the Python shell. So I can do nova.images.list, right? So again, a very long list. So how do we really quickly filter through this? Well, let's examine one of these objects. So again, let's get the first elements in this list. Let's save it to A, just so we can examine, okay? So now that we've saved it here, let's see. Let's do dir A just to see what possibilities there are. And if we examine this quickly, we can see, aha, it also has a field called names. So let's say, what is a.name? Well, a.name is the name of the image itself. So that's good. So knowing that, we can use the find function again within nova.images. So if I know the name of an image, in this case I do know, so let's see, image equals nova.images.find. Now we'll go name equals, and for the purposes of this course, well, specifically for this lab itself, oops, for the purposes of this this lab and the next lab, you should be using this image itself that I have prepared for you. So knowing that this is the name of the image, I run the find function, and then if you see image, it successfully retrieved the object EC1508-overlay. So now we have this image object here. So in order to boot up a VM on SAVI, so we need to specify a flavor and we need to specify an image, but we also need to specify which network that we want to attach this virtual machine to, right? So normally in the bash CLI, network commands are queried using Neutron, but Nova has limited capabilities to query Neutron networks as well. So again, this is another sub-function or sub-feature of the Nova clients. So if I go, let me create some space here. If I do nova.networks.list, I can see the list of networks that I can attach to. So in this case, I only see two potential networks, the external network and the network corresponding to our tenants. So for the purposes of this lab, and actually all labs, when you're creating a VM, you should be attaching them to the network associated with your tenants. And all the network names have been named such that it's simply your tenant or project name followed by -nets, right? So just keep that in mind. So again, similar to our previous exercise, let's just get the first object here and let's examine it a little bit. So if we go dir A, we can see that, interestingly, it doesn't have a name member variable. And just to verify, let me go A dots and then I'll press tab. And yeah, it doesn't have anything called name, right? But we do see something called label. So what is label? So there you go. We found out that this network objects that we've saved to A, it doesn't use it doesn't use name. It uses label to store the name of the network object itself. So knowing that, we can use the find function, just like images and just like flavors. We can go. We can use We can use Nova networks.find label equals what? Well, again, like I said, in SAVI, we've set it up such that all the network names are basically your tenant name plus -net. Actually, let me just save this into a separate variable for now. So I'll go net name equals tenant's name, which we set earlier, plus -net. So net name should be that. So given that, I'll now do nova.networks.find label. We're using label because that's what it's called for for network objects, equals net name. We'll save it to net. Great. So now that we have these parameters, we should be able to start creating a VM, right? So let's see here. So I'll just give this to you guys. There is a function called nova.servers.create, which will allow you to create a VM. But how do I know it's a function, but how do I know what parameters it needs? Well, let's try just calling this function without any parameters right now. See what happens. If I do that, I see that it's giving me an error that says it needs at least 4 arguments, right? So this still isn't that informative. So how do I figure out, what it needs? The one thing you could do is you could go on GitHub and you can try and read the code itself, right? OpenStack also does have online documentation for most of these functions as well. But programmatically, if you're doing quick scripting in a Python shell, there is a Python module called inspect. So let's import that module right now. Right? And inspect has a lot of different functions, right? If I do go inspect dot and I press tab, you'll see that it has a lot of different functions. But the one that you should get used to knowing is a function called get argspec. So get argspec as a parameter takes another function and it'll give you information about that function. So let's just go nova.servers.create because we want to know more about this function. So if we do this, we can see that the argument spec for this function, the first 4 parameters self, which you can more or less ignore because that's always supplied. The second parameter is, or the first parameter you should pass in is name, image, and flavor. And then basically those are the first 4. and we have a bunch of other optional arguments as well, right? So without going into too much detail, I'll just give you the command that you need to boot up a virtual machine. And that is, let me give it to you here. So in this case, it's nova.servers.create. This is the name of the virtual machine that you're wanting to boot, as indicated as here. The image, which we saved to image earlier, the flavor. The key name is whatever you want, right? Actually, let me check if this key name corresponds to the key name I have in my account right now, in my NetSoft 50 account. So Nova, what is my key name? All right, so I'll just use NetSoft 50 key. Sure. So let me change this quickly. So Nova 50, sorry, NetSoft 50 key. So now I've changed my key name to NetSoft 50 key. Security groups, we're using defaults. You should always use default. And then we have this parameter NIC. So if you're not familiar, NIC stands for Network Interface Card, right? So a virtual machine, like any computer, can contain multiple network interface cards. But for the purposes of this tutorial and this walkthrough, we're simply just going to attach a virtual machine to a single network. So it only needs a single network interface card. So this NIC parameter takes essentially it takes the network ID of the network that we want to attach to. And we've already saved this net object earlier, so let's run this right now. So once we do that, I'll type vn. So now it returns to me a server object, right? If I go back to the bash shell, if I do nova list again, you can see it's building a VM called my test VM, which is what's here. So I can see the status in the Python shell right now if I go vm.status, right? So it says that the status is in build state. If I come back here and I refresh this, you can see that my VM is now active. But if I go back to the Python shell and I call vm.status again, you'll see that it's still in build state. So what do I have to do? That means that I need some way of refreshing or requerying OpenStack just to see if the status has been refreshed. To do that, there's a function called get. So I call vm.get. And this will essentially refresh the status of the VM object. So if I go vm.status again, you'll see that it's been updated to active. But we want to do this programmatically within a script, right? So we can't manually call get over and over again and examine it. So to do this, you'll need to put it in a loop, and you'll need to wait until the status turns active before breaking out of the loop. And within each iteration, to avoid spamming the Nova service with a bunch of .gets to refresh, you should probably sleep between each iteration of the loop. So to sleep, you can use the time module in Python, right? So for example, you can sleep 3 seconds, time.sleep3, and all that does is wait 3 seconds before continuing, as we saw just there. So in your script, you should probably have something similar to this, and I'll paste it here for you now. So as you can see, this loop, what it does is, while vm.status is not active, I basically sleep for a set number of seconds, and then I refresh the VM state, which basically requeries the Nova service on SAVI, and then it'll check again to see if the state is active. If it is active, it'll break out of the loop. Right? So that essentially brings you through how to create a virtual machine on the SAVI testbed programmatically using the Python client. But I want to take this one step further really quickly, and I want to show you how to programmatically SSH into a virtual machine and run commands. So to do that, to programmatically SSH, you need a Python module called Programmatic. So let me just import that right here. So with Paramiko, you can create an SSH client. To do that, just run paramiko.ssh clients, and this will create an SSH object for you, right? So one thing you should always also set when working with cloud environments is this. I won't go into details about what this means right now, but if you're curious, you can look it up. There are some documents at this link here. And I'll give you a moment to go to this if you want, but if not, to pause the video and go to this link if you want. If not, I will continue. So to SSH, you first need to get the IP address of the VM, right? So we created a VM, but how do I get the IP address, right? So I need to see the networks, the network details of this virtual machine. So if I go vm.networks, right, I can see that this is essentially a dictionary mapping the network name my virtual machine is connected to, as well as what IP address it has. So let me do this. So because it's a dictionary, I can use the .get function, or I can even go netname itself. So I need the network name, and that gets me the IP addresses that I may be potentially connected to, right? So there's a reason why this is part of a list, and you're wondering why this is part of a list. And again, it's because a virtual machine may have multiple NICs, right? So if you have multiple NICs, you may potentially be connected to multiple IP addresses. So let's just do this. Because I only have one IP address in this list, I will take the first element in this list, and that will get me the IP address itself. So let me just save this into a variable called IP. Now that I have a variable called IP, I should be ready to connect. So if I take that SSH client object that we created earlier, I can go ssh.connect. The first field is the IP address. I also need to supply it a username. So for the image that we use to create this VM, which is PCE 1508-overlay, the default username is Ubuntu. And the default password that has been set in that image is simply SAVI. So if I call ssh.connect with these parameters, it'll return just fine. So one thing to note about this connect function in itself is that it doesn't return you any status. So you don't need to save any results here because it doesn't return you anything. So if I really quickly open up a browser and take you to that page, you'll see that, let me see here, you'll see that this connect function, interestingly, doesn't return anything, but what it does tell you is that it does raise exceptions if anything goes wrong. So we can try and catch an exception to see if anything goes wrong during our connection process. So you may be wondering, well, how often will there be an issue when connecting? Well, when you first boot up a VM, it may take up to a minute or two for the SSH daemon within the VM to come up, right? So if you try and call connect before the SSH daemon within the VM comes up, then you're going to get an error. So again, you can't be expected to do this manually, so you'll have to put this in a loop. And when you put it in the loop, you'll have to try and catch the exception. And if you catch an exception, you just sleep again, and then you try again. So let me do this here. I will show you how you should be doing this programmatically within the script. So let me see. So if I do this, so let's examine this code a little bit, right? So while true, basically this loophole will run forever. Otherwise, you first try and do the connection, right? If this connection fails, it'll throw an exception. It will be caught by this exception statement here. And once it gets caught, it'll print out the exception, some error message that I have, and then it'll wait about 3 seconds before the loop tries again, right? If this SSH.connect successfully connected, then we simply break out of this loop. Very simple. So now we've established an SSH connection and we are ready to run commands. So we can go SSH.exec command, and let's run something simple like ifconfig, right? So interestingly, you'll see it doesn't give you a text output. Actually, what does it give you? Well, let's go back to that page that we were at earlier. Did I close it? No, I had it right here. So exec command. So this exec command function, you'll see it returns right here. Returns SCD and STD out and STD error from the command itself, right? So to successfully run this, we should capture these returns: SCD in, SCD out, STD error, standard error, standard in, standard out. The basics of any process in Linux. So now that we've captured the outputs, so we're not using standard in right now because we're not feeding anything extra into the process, but we want to be able to see if there's anything in standard output, right? So if I just print standard output right now, it's simply an object, right? So we need to be able to read from this object. So this standard outputs, if we see what's in there, there is a function called read lines. Actually, if I go a dot, you'll see that there is a function. Interestingly, it's not here. Well, there is a function called read lines. Ooh, right, I'm using a, that's why. If I go SCD out dot, right, there's a function called read lines. Read lines will read all the lines. There is a function called read a line, singular, that will only read a single line, but I want to get all the lines at once because I'm impatient. So if I go outputs, let me just save the output. So if I go out equals SCD out equals read lines, plural. Now let's see what is in out. So this is a bit of an ugly output. What you may notice if you look at the first character and the last character is that this is a list object where each element in this list is a single line, right? So each element in this list is another line of outputs from the command that we ran earlier. So one way that we can join all the elements together in Python is to use the join function. And I want to join them together without any delimiters. So I can go, and let me save this as, let's see. So quote.join out. So basically what does this mean? I want to join every element together and tie them together with nothing, an empty, so basically they're back to back to back. So in this way, we'll get one long string. So let me print out again. And now we get a nice, pretty output that corresponds with what we expect if we had run ifconfig from within the VM itself, right? And again, I can do this. I can do this with any other command. Let's see, what do I want here? Let's see, let's print the working directory path, right? And then I can save the outputs, the outs, and then we can simply print out. And again, this is a list object, which we don't like. And then let's do the join, print out again. So now we get a proper path as we expected, not in a list object, but in a fully within a giant string. So that essentially is a simple walkthrough of how you can programmatically SSH into a virtual machine and run arbitrary commands and get its outputs, right? So now let's say you're finished using the virtual machine and you want to delete it, right? So to delete it, if you still have that VM object, you can use it directly. If not, you'll need to use the find function to find the object itself. So just to ensure we're not crazy, we still have that VM object here, right? To programmatically delete a VM, there's a delete function, and you simply just call it without any extra parameters. So you just call delete. That will begin the deletion process. If I come back here to the bash CLI and I do nova list again, I see it's gone. So there you go. So hopefully from this simple walkthrough, you've learned how to quickly prototype pieces of code from within the Python shell. And using that, once you prototype small snippets of code, so line by line, and you know what lines work and what lines doesn't, you can begin to copy and paste those lines that you know that work into a separate file that you can later run as a wholly working script, right? And hopefully this will give you a good starting point to begin the lab. I hope this was fruitful for you guys, and if you have any questions, please post on Piazza. Thank you.